Day 2, we're going to start talking about parallelograms. With parallelograms, you're going to notice that we spend a few days talking about the parallelograms because the ideas are so important in order to learn about the other shapes as well. So we know that in a parallelogram there are 6 properties, and you can see those 6 properties listed here. And those 6 properties are things that you want to make sure that you have memorized. So it's super important that you understand the vocabulary and what they actually mean. So if I was to tell you that this quadrilateral that we have right here is a parallelogram, and that we're going to call the parallelogram EFGH, you would see that written like this, the word para, and then the letters E, F, G, and H. And just like we talked about last week when we talked about a trapezoid, when we name them, it really doesn't matter where we put the first letter. A lot of times I'll put E in the upper left-hand corner, and then you have to work your way around the shape. So what you'll notice is you'll see me go clockwise around the shape, just like we did with trapezoid, so that when we end, we go right back to the beginning. So that's what you'll see me do most of the time. Really doesn't matter where the E goes, the starting letter, and it really doesn't matter which way you rotate around the shape. You just have to make sure that you go around it and not cut through it. So in the properties, it says opposite sides are congruent for property number 1. That means that the side EF and the side HG are congruent to each other. So one of our pairs of opposite sides that are congruent are EF congruent to HG. The other pair of opposite sides that are congruent are going to be the two that are the left and right ones. So there's a second set of opposite sides congruent. Some of you may look at that and say, okay, well, what am I supposed to do? Which one do I pick? And we make that determination by what the proof or the question is talking about. The second thing that you see in our list of properties of a quadrilateral is that the opposite sides are parallel, both pairs of opposite sides actually. So not only are the top and bottom ones parallel to each other, EF parallel to HG, but so are the left and the right. So these are parallel to each other as well. So HE is also parallel to FG. Those segments are parallel. Opposite sides are parallel. The third property that you will see here is that opposite angles are congruent. Opposite angles are the angles that are across from each other in the shape. So in this case, we have angle H congruent to angle F. And we also have the other pair of opposite angles being congruent to each other as well, which is angle E congruent to angle G. The next property, number 4, is talking about a diagonal dividing a parallelogram into 2 congruent triangles. This is one of the circumstances where you have to be a little extra careful to make sure that you're understanding what that reason is saying. That reason is saying that if you draw one diagonal in, and I'm going to put this over here. So here's my parallelogram. I'm going to redraw it so you can see what's going on. And with my parallelogram, E, F, G, H, I could draw a diagonal in this way, and that would give me 2 congruent triangles. I would have triangle EGF congruent to triangle GEH. The reason why I'm doing these separately over here is because I also want you to know that if by chance in your parallelogram EFGH you drew in the other diagonal, you would have another set of congruent triangles. So it's not the same set, it's a different one. So this is triangle EFH congruent to triangle GHF. So a diagonal divides the parallelogram into 2 congruent triangles. Which one we pick to look at is going to either be the one that's drawn in the picture, or it'll be the one that makes sense based on what the question is asking us to do. All right, so moving on, we have that the diagonals of a parallelogram bisect each other. I'm actually going to change this and put an S in here because the reason doesn't make sense unless you're talking about both diagonals. So it says that when you draw those diagonals in, they bisect each other. We already know what a segment bisector does. A segment bisector creates a midpoint. So what would happen is where they intersect, you would have a midpoint. So based on this number 5, I'm going to put in here that we would know that EG is bisecting FH. One diagonal bisects the other, and vice versa. FH will be bisecting EG. And from that, please remember that those are segment bisectors, and segment bisectors create midpoints. So I'm just kind of giving you that little reminder of what you already know about a segment bisector. And then, of course, once M is the midpoint, you would know that the two parts are congruent on one diagonal and the two parts are congruent on the other diagonal. And then the last thing that we have to talk about here is that any set of consecutive angles will be supplementary to each other. Consecutive means next to. So it could be the case that I'm talking about angle E and angle F as being supplements, or it could be that I'm talking about F and G as being supplements, or it could be that I'm talking about G and H being supplements, and then the last scenario, it could be that H and E are supplements. So there's a whole bunch of supplementary angles in there. Usually we use this as a reminder that the consecutive angles add to 180 more frequently than we use it in a proof. So usually used more algebraically than in a proof. So as I said, you want to make sure that you have those memorized. Eventually we will have a quiz on those. You want to make sure that you have all the properties memorized because every shape that we're going to talk about from here on out is going to be using those properties. So if we take a look at the first question that goes with this, we can see that it's a proof, and they are telling us in this proof that we have a parallelogram right here. So one of the things I want to point out to you is that because we know that a parallelogram has 6 different properties, I consider this to be a gift. The problem is that I don't want to just reach into that and start pulling all this stuff I know about a parallelogram out. I want to pick and choose. When they give me that gift, pick and choose what I need to make this proof work. So I'm going to leave that sitting there for a second, and I'm going to go ahead and move on to the fact that CD and CE are congruent. As soon as I color those two, what I notice is that those are 2 sides in one triangle, which means that these opposite angles will be congruent to each other. Angle E I can call angle E, but the one angle, angle CDE, CDE, when we look at that angle, we can't just call it angle D because there's more than one angle D. So let's give it a number. Let's call it angle 5. So because of the blue line segments congruent, I will know that angle 5 is congruent to angle E because if 2 sides of one triangle are congruent, the opposite angles are congruent. When I get to this point, I'm still not sure what gift I'm going to pull out of the fact that this is a parallelogram. So what I'm going to do now is I'm going to turn my focus over to the prove line. And the prove line is talking about angle A and angle E being congruent to each other. The problem is right now angle A isn't even in the proof. So I have to look at a way to bring angle A into the proof and find a way to say, oh, I know angle A is related to some other angle, and how? So one of the things that I notice is that this angle A here is actually congruent to the angle that I called angle 5. Remember from previous units, if you have an F shape, and the angles in the little pockets of the F are congruent to each other, I'm sorry, I'll take that back. If you know that the lines are parallel, you know that the angles in the little pockets of the F are congruent to each other. So in this case, if there was a way, let's just think about this, a way for us to get these sides parallel, we could use the rule here that if lines are parallel, corresponding angles are congruent. Remember, out of this gift of a parallelogram, one of the things that we know is that opposite sides are parallel to each other. So in my proof, if I identify that line segment AB is parallel to line segment DC, because opposite sides, and you always want to make sure that you're stating of the shape, so I'm going to write of a parallelogram are parallel. Once I know that they're parallel, then I know that those angles are going to be congruent. So in here, I'm bringing angle A into the proof by saying it's congruent to angle D. Well, I better call that angle 5. Angle 5, because if lines are parallel, corresponding angles are congruent. So right now, when I take a look at my proof line, what I know about my proof line is that I need to get angle A congruent to angle E. Angle A is right here, congruent to angle 5. And angle E is right here, congruent to angle 5. And what we know is if angle E and angle A are both congruent to angle 5, then angle A must be congruent to angle E through a process we know is transitive. So I have two sets of congruents and one link, and that is going to be transitive. So in this proof, even though I'm given a parallelogram which has a lot of statements that we know to be true, a lot of properties about it, I pick and choose the property that I want to use. In this case, I only used the one property, that the opposite sides were parallel. In another proof, we might use more properties. You have to base it on what you see going on in the question. For the second proof is one that shows a little bit of potential to possibly make triangles congruent, because I do see two congruent triangles in it. And I do see that they're giving me that same gift again, that I have a parallelogram. But remember, I'm going to be a little careful about what properties of a parallelogram I use. And when I take a look at this proof, the very first thing that they give me is that FD and BE will be congruent to each other. So if I use my hunch that I might want to make the triangles congruent, the one that's in the lower left and the upper right, I would say that that would be a set of sides. So I don't know for sure that I'm making triangles congruent, but it might be a good way to head through this proof, at least initially. When I do that, I'm still stuck with saying, what am I going to do with this parallelogram? So I'm going to turn my attention over to what the proof line says, which is that line segment AF is congruent to line segment EC. And when I look at that, I can see that those are sides of two triangles. And it would be nice if I could make the triangles congruent, because if I could, then I would be able to go through and do CPCTC. So the shape that's the parallelogram, you have to be a little careful on this, is the shape that's right here. So that's the parallelogram that we're talking about. In here, one of the things that I know is that opposite sides of a parallelogram are congruent, which would be a great way to state that those two are congruent because they're opposite sides of the parallelogram. But in this case, not only are they opposite sides of the parallelogram, but they are also going to be considered a set of sides between the two triangles. My reason for this is opposite sides of a parallelogram are congruent. From here, there's a couple of different ways that you could do this proof. It kind of depends on what you see. I'm going to use a specific way to go through now and end up making the triangles congruent. And I'm going to do that by directing your attention to this angle 1 and this angle 2. Angle 1 and angle 2 are opposite angles of the parallelogram, which means that they're going to have to be congruent to each other. So if opposite angles of a parallelogram are congruent to each other, some of you may be saying, well, why would we be talking about those angles when they're not inside the triangle? So they are angles inside the parallelogram, but they're not angles inside the triangle. And the reason why I'm choosing to talk about it this way is because some of you, I'm sure, have already noticed that there's a relationship between angle 3 and angle 1. They're linear pairs, so they're supplementary. And there's a relationship between angle 2 and angle 4. They're a linear pair, so they're supplementary. This is another one of those circumstances where we have angles that are outside the triangle and we want to convert them to inside angles using supplements. So in my proof, I'm going to put that angle 1 is a supplement to angle 3 and angle 2 is a supplement to angle 4 because linear pairs are supplements. Number 5, please remember that here we said that 1 and 2 were congruent. That's the same 1 and 2 that I have here, which means then that angle 3 must be congruent to angle 4 because the supplements of two congruent angles are congruent. And that gives me a set of angles. So when I get to this point in my proof, I have gathered up, based on the 3 things along the left here, a combination of 3 sets of sides and angles that are congruent. When I go to look at my 2 triangles, I can see that triangle ADF is congruent to triangle CBE by side angle side. And the reason why I wanted those 2 triangles congruent was because I wanted to get line segment AF congruent to line segment EC. And now I can do that because the triangles are congruent, so are all of their corresponding parts, so CPCTC. So in this particular proof, we actually used 2 properties of a parallelogram, they're both listed here, to get to the final proof line. Sometimes you might need 1, sometimes 2, sometimes more than that. It just depends on the question and what it's asking. The next set of questions are algebraic in nature, and they're still using the properties of the parallelogram that we talked about initially today. So in question number 3, they're telling me I have a parallelogram. The wording for the directions tells me I need to draw and label a picture for each, and not only solve, but give some kind of justification. So I want to make sure that you understand exactly what it is that you're supposed to do with that. So I have a parallelogram that I'm drawing. The name of the parallelogram is MATH. MH, we know, according to this question, is 2x plus 5, and AT is 14 minus x. One of the properties of a parallelogram is that opposite sides are congruent to each other. So my justification for this question is going to be opposite sides of a parallelogram are congruent. And I'm going to put that the 2x plus 5 equals 14 minus x. And when I do my solving, I get that x is 3. You'll notice I did not spend a lot of time talking about how to do that solving. My main concern is that you know this, that the opposite sides are congruent. In question number 4, it is a parallelogram called HELP. So when I draw this parallelogram, I want to name it working my way around the shape. Angle E, they tell me, is 4x plus 4. Angle P, they tell me, is 74 minus x. The rule that I'm going to be using for this is that opposite angles of a parallelogram are congruent. So in this case, I'm going to be putting the 74 minus x equal to the 4x plus 4. which will give me 5x equals 70, and x is 14. Question number 5, parallelogram BEAR. When we do this question, we'll start it the same way. So BEAR. In this case, angle E is 2x plus 9. Angle B, 5x plus 3. And in this case, these angles are not the same kind of angles as in the last question. These are what we call consecutive angles. They're ones next to each other. And in this case, they are supplements to each other. So my justification is going to be consecutive angles of a parallelogram are supplementary, which means that 5x plus 3 plus the 2x plus 9 is going to add to 180. So 7x plus 12 equals 180, minus the 12 from both sides, and 7x is equal to 168. And then when I go through and solve, I get 24 for my value for x. The next page has a couple more questions on it. Let me flip over here. Question 6, parallelogram ABCD. Diagonals intersect at a point called E. Angle ABE, that's this angle right here. I don't really have room to write it in there. I got to write it on the side again. Is 3x plus 2. Angle CDE, that's this angle, is 2x plus 15. And again, I don't have room to write it, so I'll write it on the side. This actually has more to do with the fact that you see this Z shape than anything else. The problem is that when you have that Z shape, the angles that are the alternate interior angles are only congruent if the lines are parallel. So in my justification, I have to start out, I'll put J1 for justification 1, by saying opposite sides of a parallelogram are parallel. But justification 2 is that if your lines are parallel, the alternate interior angles are congruent, which means that the 3x plus 2 is going to equal the 2x plus 15. And then when I go through and solve this, I end up getting that x is 13. That looks like a B. X is equal to 13. Question number 7. Again, another parallelogram. JKLM. Diagonals, they're talking about both of them. I draw them in. Point of intersection is N. It tells me that the part that goes from J to L is 4x plus 6. And the part that goes from L to N, I'm just going to change my color here. L to N is 3x minus 1. And we have a property in a parallelogram that says the diagonals of a parallelogram bisect each other. And then what that means is that we have a segment that's going from J to L, and when the other diagonal KM cuts through it, it's turning point N into a midpoint. And if N's a midpoint, then we know that the two parts are equal. So if one of the parts is 3x minus 1, so is the other part. So in this case, not only do we know, justification, I'll change that to a 1, that the diagonals of a parallelogram bisect each other, but we also know that a segment bisector creates a midpoint, which is what we identify point N as. And then justification 3 is that the midpoint divides the segment into two congruent segments. So our midpoint N split JL into two equal parts. If one of them's 3x minus 1, then so is the other. So I have two 3x minus 1 segments that equal the 4x plus 6. distribute, solve, and I get x is equal to 8. In this question, I just have to be a little careful at the end because they were asking me for how big JL is. So I know in this question, JL is 4x plus 6, which is 4 times the value of 8 plus 6, which is 32 plus 6, which gives me JL is equal to 38. So you just want to make sure you don't forget to go back and answer the question. Question 8. We have a parallelogram, ABCD. It's talking again about the diagonals intersecting at E. It's talking about angle AED. I'm going to change my color up here. AED, and they're saying that it's 6x minus 2. They're also talking about angle BEC, which is here, and saying that it's 4x plus 12. In this particular case, there actually isn't a reason about a parallelogram that's going to be telling us what to do with those two angles. Our justification here is that these two angles are vertical angles. So we're only using the reason vertical angles are congruent here. So sometimes your shape might be a parallelogram, but there's other stuff that's going on. We're not actually using one of the properties. So the 6x minus 2 is equal to 4x plus 12. I get 2x is 14, and x is equal to 7. When I go back and I check to see what the question is actually asking me to find, they're asking me to find angle BEA. That's this angle. So when I'm looking at that part and I'm going back to find...
Please contact the main office at 8513, Mr. Dave Miller. Please contact the main office at 8513. Thank you.
I apologize for that announcement. So they're asking for angle BEA. That's the angle that they want to find the measure of. And what I have to recognize, this is going to be what my justification for this one is that these two angles, because they sit on a straight line, are supplementary. So the first thing that I have to do to solve this is take the x value that I got of 7 and put it in here. So that's 6 times 7 minus 2, that's 42 minus 2, which is 40. So this angle here is 40, which means the angle that's here, its supplement, is 180 minus that 40, which is going to give me 140 degrees. So my angle BEA turns out to be 140 degrees. So didn't really use a property in there at all to deal with the parallelogram properties. Over here, we talked about how vertical angles are congruent. My other justification is going to be that linear pairs are supplementary. So once I take the value of 7 and I substitute back in, I have to think about the fact that these two angles are supplementary because they're sitting on the straight line. Once I find the angle BEA, then I can go back and say the one next to it must be its supplement.